Hello everyone. In this video, we're going to cover part 2 of the CSI-RS for 5G, where we have covered 3 parts in the last video, what was mainly related to the main function of CSI-RS and K characteristic, and also we went through the types and the categories. Now we are going to cover the 3 remaining parts, which related to the parameter, most of the parameter description of the CSI-RS, and also we'll try to visualize the resource allocation of the CSI-RS whenever the E node B is configuring and allocating those resources to the users. Then we'll go through high level introduction about the planning or planning consideration of the CSI-RS reference signal part. Before jumping into the parameters part, I would like to recall the knowledge about the types and the categories of CSI-RS in case you didn't watch the first video. So I will need first to cover this part. And in case if you watched the first video, you can skip this part and jump directly into the CSI main parameters. So let me take you here. So the first part here, just as you remember, we highlighted that we have 3 types of the CSI-RS. The first type was relating to the non-zero power CSI-RS, where it's having 2 categories. That the first part was related to the channel management, which we call it usually CM. This CM channel measurement, I mean, not measurement, channel measurement is responsible for the channel measurement, for example, for the UE reporting the channel state information such as CQI, BMI, and so on, and also BM or HB management, and also radio link failure monitoring and detection, and also related to mobility and beam recovery and failure detection. The second category was related to the interference measurement. If you remember this part, we gave an example that non-zero power CSI resources can be configured for IM, which means interference measurement, to measure the interference, for example, caused whenever you have a multi-user MIMO, which can be caused by another UEs within the same cell. The second type, which was about the CSIM or CSI interference measurement resources, and this one, as we mentioned, it was mainly responsible for intercell interference, and we highlighted the very important point that this part, the serving cell is not transmitted any data or anything at this particular CSI resources to be able to measure the background noise caused by the neighbor cells. And both those non-zero bus CSI-RS and CSIM is being reported within the CSI report configuration, and this sending by the RRC configuration message in 5G standalone, and this is going to be addition acknowledgement within non-standalone. The last type was about the zero power CSI-RS, and this one having only 1 category. And as we mentioned before, that this one is mainly used for rate matching pattern, where can be used to inform the users about the resources which can be used for BDSH, for example, free resource of BDSH, and details has been covered in the previous video. Now let's go through the parameters part. Before taking you into the parameter description, I would like just to give you a high-level introduction about the layer 3 parameter structure and frame of CSI report. What it means by this. Usually when you check the layer 3 messages, especially for the RRC configuration message or SHNB addition, for example, request acknowledgement, as I mentioned, uh, this actually would be the structure. You will find first something called CSI report configuration, and this CSI report configuration will having these 2 messages below it. The first part will be covering, for example, what kind of CSI report configuration ID. For example, the ID for example, if it's used for non-zero power, it will give an ID for non-zero power. If used for CSIM, it will be used for CSIM, which is the interference measurement. And this actually for the CSI report configuration, this is under RSC configuration message. Then also within this part, it will having another information regarding the report configuration type, whether it's periodic or aperiodic, for example, or semi-persistence. Also there is much more additional information which more relating to the channel state information reporting. For example, the report quantity, whether it's like required for CQI, BMI, RI, and so on. Also, for example, the granularity. For example, you want to measure the CQI for wideband or subband and so on. This is much more information. This will be covered. The third point will be covering in a different video, which is more related for the channel state information, because channel state information actually has more details that need to be covered in a different video. Under the CSI report configuration, you will go through under this message, you will find something called CSI measurement configuration. This CSI measurement configuration, actually, it will having this CSI resources. This one specify what type of reference signal CSI reference are going to be covering the information or going to be measured. For example, here there you have a non-zero power, or you have a, for example, non-zero power for CM or CSIM and so on. This is which is going to be transmitted by the unit B and measured by the UE or unit B. Transmitted by unit B and measured by the UE. The last part within this CSI resources, you will have many information which we are going to cover in today's video. This actually define all the relative physical resources for individual users. What it means by this, for example, it's informing the users what is the symbols, the exact location of the CSRS, at which symbols, for example, what is the density, how many ports, and so on. And this is actually what we are going to cover in details in the next slide. But before going to the parameters as well, I would like to recall the knowledge about the basic CSI-RS structure. As you can see in the figure on the right, the CSI-RS actually is occupying only one RE as a minimum unit. It's one RE, which is equivalent to one symbol within a resource blocks. So this is the minimum unit for this part. So this is the first part we would like to highlight. Second part, that as we highlighted, that the CSI-RS in general can be configured up to 32 ports. It can be 1, 2, 4, 8, 16, and up to 32 ports. And I will be giving more details about this part, what is the benefit of increasing the number of ports and so on. But the main point here that increasing the number of ports, this means you will have more CSI-R resources. So this actually will giving higher density. So this is can giving more accuracy during the measurement and so on. I will be explaining or giving the advantage and the disadvantage of increasing the number of ports. The third point, which is also important, that usually the CSR is always configured per device basis. For example, each user will be receiving RS serial configuration message, which covering the resources location and the quantity of the CSI-RS. But actually, this is not doesn't necessarily mean that the transmitted CSI resources can only be used by a single device. No, still it can be shared by different devices, and actually that's there where the number of ports, different ports coming into figure. But still, as I mentioned, it's being configured per device basis, but it's sometimes can be the same resources can be shared by different devices, but using, for example, different ports. The last point here, what we are going to cover, that this one, as you can see here, I highlighted only one location here, but it can actually, the CSRS can be configured at any location. But uh, there are some restrictions actually to avoid collision with other physical channel signals, such as, for example, the core set or BDCH DMRS, or the last part which is related to the SSP, which is being considered by the users and also more by the Unit B during allocating the CSR resource. Now let's jump into the parameter description, which is the more interesting part in this session. Okay, actually, as you can see here, this is we have a very big table here. This big table, as you can see, it's having several parameters, and this all several parameters I will be going one by one now. Then I will try to visualize the next slides. First of all, I would like to tell you that this kind of information, all these parameters, you can find it in a non-standalone network. You can just go check the RSU configuration message. You will find it, for example, if you are looking for non-zero power or CSIM, this information will be found within the CSI measurement configuration. And if you are looking for zero power information, so the information will be you will be found within something called BDCH configuration. This is in standalone network. In non-standalone network, you can check the same these two same messages, but this will be under SNGB additional request acknowledgement. This is a non-standalone network. Now let's go through one by one and just give a quick description. Then we try to visualize the next slides. For example, the first part here is called something called row number, which means actually frequency domain allocation. This kind of information is just define the subcarrier location for this particular UE. For example, I'm telling him you are going to use row 1 or row 2 or row 4 or others. I will be giving examples for each one of those. But row 1 and row 2 and row 4, this is explicitly mentioned to the users. Actually, this information is referring to the 3GPP table, where it's having a combination of different parameters to inform the users about his frequency domain or subcarrier spacing and also the time domain and so on. So this actually, as you mentioned here, this will be mentioned as you can see in the layer 3 messages. The first part here is related to the resource map. This is all under the resource mapping. The first part, for example, frequency domain allocation. Under this one, you'll find something called other. For example, here other, as you can see, or you can find sometimes mentioned as row 2 or row 4 or row 1, and each one of those having a number of bits. And actually, this one is referring to a particular parameter called K. I will giving an example of this, but just in summary, the main function of this frequency domain allocation is just allocating or specifying the starting subcarrier. which subcarrier the CSI-RS will start. For example, subcarrier 0 up to 11, or 0 or 1 or 2 or 3, and so on. The number 2, actually, which is very, very important, it's related to the uh, number of ports. Actually, as I mentioned before, the number of ports can be 1, 2, 4, 8, or 16, and even up to 32. Okay. The main idea of the number of ports, as you can see here, first of all, that the number of ports, the increasing the benefits of increasing the number of ports, it actually provides a higher granularity in the beamforming, better granularity in the beamforming. This actually can give some improvement in during the measurement or accuracy of the CQI, and also can improve the rank indication, and also can improve, for example, the 256 QAM, as long as you improve your CQI and ranking, and also this can give some improvement in the user throughput. However, this will be in favor of the maximum user throughput, because as long as you're increasing the number of ports, this means you are increasing the overhead of the CSI resources, and this will be more clear in the next slides as well. But just in general, increasing the number of ports, this will be having more resources of CSRS, and this is giving more accuracy during the measurement of the UE. So this one can give much better uh, or more clear information, more accurate information whenever the user is going to report the channel state information, which include the CQI, BMI, and so on. The third point here is related to something first of the more simple time domain. I think the name is very clear. The first parameter, frequency domain, was like telling him which subcarrier. This one will tell him which symbol is going to be used for the resource allocation. And actually, there is two parameters from this one. This is just like something related to I0, I1. It will be in the table, but it's not really needed to know like the details about this first and third parameter. You just need to understand these two parameters is responsible for to allocate or to inform the users about the starting subcarrier and the starting symbol, and this one will be explicitly mentioned, and you can see it here in the right. First of these symbols, for example, it's mentioning this 13 and so on. So going forward, and also the number of ports here, you can mention that, for example, B8, this means 8 ports. Going forward for this one, we have something called CDM type. Actually, the CDM type, this CDM type is just like mentioning, like highlighting. This also will be within the 3GPP table to just inform the users, for example, if they're going to be, if you're using different ports, should be some, for example, code division multiplexing, or frequency division multiplexing, or time division multiplexing. Actually, I will be explaining this one also in the visualization example, but I just can give you a quick example. If D or CDM2 means, actually, for example, this means 2 means you have two resource elements, two resource element, like will be two resource element will, like we're using different code division multiplexing, will be using two different subcarrier location, or two different locations, because this one also, as much like highlighting here, is FD means frequency division, so it means that you will have two resource element, but code multiplexing. This one I'll be clearing in the next visualization example. Then going forward for the density, this, for example, highlighting how many resource elements will be sent within one sample. For example, if 3, this means you will have 3 resource elements. If for example 1, this means you will have 1 resource element within the time, or within the symbol, and so on. So you can have, for example, if 3, you can have up to 3 CSIRS within the same, and so I will be giving example of this part. Then the frequency band, this one is responsible to highlight just what is the starting result logs and number of result logs in total, which being measured by during the CSI-RS reporting. And as I mentioned, all these parameters, it's resource mapping. It's actually all of this one is pointing into or referring to a 3GPP table where the users will take this all this information and start calculating and finding and detecting where is the resources and the exact information about the resource allocation with CSRS. I will be giving an example of this part, but just the takeaway of this part, the main parameter which we usually control, it's a number of ports. All the others, usually we don't have a control over it. Uh, number of ports. You can, for example, look into the parameters. You can increase it, reduce it, and so on. For example, you can increase it to increase accuracy. You can have improvement in SQI, rank, and so on. But the increasing this one also will increase overhead, and it will impact you maximum user throughput and so on. So this is the main takeaway, that this is the main parameter where we can control. Going forward now for the other 3 parameters. The first one is related to something called power power control offset. Actually, this power control offset is specify the transmitted power differences between CSIRS and BDCH. For example, This is what it means by this one. This, for example, it's specifying the offset of the CSI-RS compared to the BDSH. So this means that the larger value of this part, of this parameter, for example, you're giving higher values, this will a larger part of the CSI-RS, and will give much better coverage, CSI-RS coverage, but it might having a higher intercell interference. For example, if you assume that the CSI-RS and BDCH, for example, in the neighbor sites, CSI-RS will make interference on the neighbor BDCH, and also this can impact the BDCH because you will have less BDCH power and can having less CQI. So usually this part is set to 0. There is I didn't go and tune it before, but usually this one in the most network is set as 0. Then the next part is about it's equivalent to the first part, but this one actually will be between the CSI-RS and synchronization signals, and the same if you increase the CSI-RS. So this means the SS power will be less, so you might having less accessibility and so on. And also this one usually is 0 and so on. The last part, which is actually we usually look into in any network as well, this is related to the periodicity. For example, what kind for CSI-RS, if you are speaking about periodic and semi-resistance, this is not applicable to the aperiodic. For example, if you're talking about the periodicity for this part, that for example the user will start understand that you will be receiving the CSI resources, for example, every 40 slots, or you can, let's say, 40 millisecond, 80 millisecond, 120 and so on. And usually the default value for most of the networks and vendors is around 14 millisecond. And here, the figure on the right, this is actually the same information in the table, but this is from the layer 3 messages. You can, as mentioned to you, that in standalone, just look into RSC configuration message. You will find it under the CSI measurement configuration, and you will find all this information, and you can start reading exactly the same information which is giving here in this particular table. Now, let's go next. But before going to the visualization part, I would like to inform you that usually you need to check the capability message. For example, if you're doing testing, let's assume that you would like to increase the resources for the ports to 32. So in this case, you need to confirm whether the device is supporting or not, because you have some the device capability can actually having different information about many information about the CSI-RS. But here I'm just addressing the first part related to how many ports can be supported. For example, here mentioned 16 port, and also, for example, here under the physical parameters, and this one under the codebook parameters. For example, this one highlighting that the CSI-RS for interference management is being supported by this particular users. This means that some users might not support. So this is also important information you should know, that, for example, during the testing and so on, that not all the devices supporting the maximum 32 ports or whatever. So also this means that GNB will be considered the EU capability during allocating the ports based on the EU capability reported by the users and so on, especially for the ports part. Okay, moving forward now, let's first take the first example about the periodicity part. So the periodicity part actually, or the report config type, I didn't highlight it in the parameters, but this one under the main parameters of the CSI report config. This is actually the periodicity of the CSI-RS, whether it's periodic or semi-resistance or aperiodic. First of all, the periodic part, this one means that the users will keep receiving the CSI-RS within a particular period. For example, here we highlighted 4 slots, which means 40 milliseconds. So every 40 milliseconds, the user will start receiving, and he can the GNB will be transmitting every 40 milliseconds the CSI-RS, and the users can start measuring the CSI-RS and so on. Semi-resistance is actually equivalent. It's like also periodic, but the main difference between both of them, this one is not necessary to be transmitted all the time. It can sometimes be deactivated by the GNB. This actually, it's being sent through the deactivation through the MAC control element, MAC. MAC control element by the unit B. So this is actually following the same periodicity. For example, if you're assuming 40 milliseconds, it should come every 40 milliseconds, but as I highlighted, it's not necessary to be off or on all the time. So this having more control. The last part actually is related to aperiodic. It doesn't have a periodicity because this one event based. This one will be triggered by whenever DCI is being sent from the unit B to the users and so on. So this is the first parameter about the CSI resource type. Moving forward now, before jumping into the visualization part, I would like to take you into this very big table. And this is a table which is having a combination of 18 parameters as 18 combination, 18 row. And I have highlighted many parameters in the beginning. If you remember, in the table, we have a port number, density, STM type, and this is K and I. K and I, actually, this is related to the two parameters, which was calling frequency domain allocation and time resource first of the email symbols. And all these parameters, the users will be reading the parameters from the table, which from the message which we're showing in the layer 3 RS configuration, and will start calculating the resource allocation type. For example, here you have mentioned port 1 and you have density of 3. This is actually the first one is mainly used for the TRS tracking reference signal. And here all the different combinations. For example, as I mentioned to you, you have from 1 to 18, and each one having a different number of ports. For example, the first one here for the first port, this is mainly used only for tracking reference signal. For example, here mentioned density 3. So you have 3 RS within the same symbol. And also this is mentioned one port. This means you will have only one port. You will not have additional ports, and see this only using one port. The second type, for example, here it's missing no code division multiplexing, and also having one port. And it's also having density 1, for example. This means you will have only one resource element. And actually this one is usually used for the beam management. Let's take some examples of this part just to try to read and understand how these resources is being read or decoded by the users. And actually this information, it's like going into details, but it's not really needed during our optimization. You just need to understand the parameters differences, the meaning of each and every single parameter, and highlight it before we have more control over the number of ports, which we can control it, for example, to improve our user throughput. So let me take you through examples for one of each of those rows, just to try to make it easy, more easy. Okay, now let's try to visualize some of the 3GPP tables examples to try to apply the parameters which we have went through it in the previous slides. So for example, here I'm giving examples for the first two row 1 and row 2. And this is as per the 3GPP information. And as you know that the port number of ports and density and CDM type is being transmitted, even the row number, as this was, for example, the parameter which is being mentioned, that frequency domain allocation. For example, if it's saying row 1, so this one will be explicitly mentioned that the user will directly know all the information for example, no CDM and the density and so on. For example, in row 1 here, it's showing different information. Let's go through it and just to explain it. First one is showing that it's row number 1. You have only one port. You have three, the density is 3. This means you will have 3 resource elements within the same symbol. Then this means the no CDM because it's only one port, so or one port, so there is no requirement for the code division multiplexing. Then this K parameter is and I can be calculated through the frequency domain allocation. For example, I will go through this part, but this is just to use to calculate the number or the location or the frequency domain. For example, where the users will start decoding the location domain, for example, which subcarriers and so on. Then here, for example, mentioning the CDM group index. We don't have any CDM group here. Then here giving information about the K dash, because this K is equal to K0 plus K dash. So this is for this part. So this means that in this case, K dash will be equal to K0. This is kind of complicated, but let me go through the visualization just to make it easy for you. For example, here this is a one resource box. Assuming that the row 1 is saying that you have only one port, this means we have only one port. So we'll be starting with the first port, which is 3000. Usually the users will start with the first port, 3000. So here it's mentioning that the row 1 frequency domain allocation, this part, it's equal to 0010 because this row 1 is having 4 bits. So here we need to get the K0, the users need to get the K0 information to start locating the subcarrier locations. For example, the K0 is set equal to the bit position. For example, here the bit position is 0, 1, 2. This means the K0 is equal to 2 at this particular case. If you assume that it's coming at the last bit is 1, and the first 3 is 0, this means it will be at K0 is equal to 3. So 0, 1, 2, 3. So this means K0 is equal to 2. So we just need to, the users will go and calculate the K0 here. So we know where is the subcarrier spacing for these three subcarriers or 3 source elements. For example, the first one will be K0 equal to 2. So it will be starting at the first one as 2. Then 2 plus 4 will be 6. So you know the subcarrier spacing is 6. Then, for example, 2 plus 8, this means that the subcarrier spacing will be at 10, at number 10. This is the location of the subcarrier. But still, he don't know the frequency domain. This also will be explicitly mentioned to him. And also within the RS configuration message, that first of the ensemble will be 5. So he know that this is where the time domain allocation will be. So the users will be able now to detect the CSI and start decoding the CSI and so on. So here it's so amazing again. Density is 3. That's why we have 3 source element. And this particular case actually is mainly using for the TRS, which tracking reference signals. Second example, it's very similar for this one, but it's more easy because this one doesn't have more calculation. It's just K0. So this means, for example, you have row number 2, you have number port 1, but row 2 is having 12 bits because it's only one resource element, so it will be having all the number of, for example, subcarriers. That's why it's 12. So, for example, here it's showing that number 1 here, the K0, you need to calculate the K0. K0 is, for example, it's like you need to find the, as mentioned here, the bit position. So the bit position is located at number 2, right? 0, 1, 2. This means K0 is equal to 2. This means it will be at subcarrier spacing. Assuming it's coming at the last bit, as 1, this one should be set to 1 at the last bit, so all will be 0 except the last one. This means it will be at the last subcarrier. So we are expecting that the non-zero power CSI-RS will be located at this particular space because also the frequency domain is 5, so it will be 5 at 11. So you find it here if it's this bit is 1 and all the other is 0, but at this case which I highlighted here, the K0 is equal to 2, so it will be at subcarrier spacing 2 and frequency domain 5. Actually, both those cases is using a single port. All the other cases is exactly the same. However, it's having more antenna ports. So I'll be highlighting 2 more cases for antenna ports. But this is just examples to let you know. It's just for understanding, to understand how the user is decoding. But we don't really need this kind of information. It's something being done automatically by the users. We don't really need to understand it. As I mentioned before, we just need to understand the parameter description and also to need to understand that which parameters we can have a control over it, such as the port configuration and so on. So moving forward for the next example, for example, this example I'm giving here for the row 4 example. This actually, for example, if you can see, it's showing that you have 4 ports, 4 antenna ports. This means we'll be starting from 3000 till 3003. And here is highlighting that density is 1. This means we'll have only one resource element per symbol. And here is highlighting FD and CDM2. Actually, this means that you will have frequency division along with CDM, code division multiplexing. 2 means that you will have 2 groups over the CDM. For example, the first group is 3000 port, combining port 3000 and 3001. Second group is combining port 3002 and port 3003. And this is the formula where you want to calculate the K. K, as I mentioned, it's equal, this one is equal to K0 plus K dash, which is K dash, you have 2 values here, 0 and 1. But this is no need to calculate it. Just I will tell you exactly, assuming now that the frequency domain allocation is coming as row 4010. After the calculation, it will be found at the subcarrier 4, 5, and 6, and 7. So we know that all the subcarriers which we have it in the 4 ports will be equivalent to subcarriers 4, 5, 6, and 7. As you can see here, this is the final figure. You will have 4 subcarriers here. So how this one actually is being figured? Actually, this figure illustrates example for CSI research for row 4 as I highlighted, and in this case the allocated resource element are assigned to CDM groups, different CDM groups. The first CDM group is port 3000 and 3001, and actually they're sharing the same resource element allocation, but belong, as you can see, the same resource element is being shared by both of them, but belonging to different groups. So they can having a code division multiplexing, which will be orthogonally allocated to each other. So still it can be allocated. And similarly, actually for the other group, CDM group, which is port 3002 and 3003, but they are starting a different frequency domain allocation, which is here. That's why we have this FD and CDM frequency division multiplexing, because they are starting at a different frequency domain, which is at 6 and 7, for example. But again, they are sharing the exact same location, but again, they are orthogonally allocated to each other. That's why it's using code division multiplexing. So actually, in this case, we can summarize it that this particular case is using a combination of frequency division multiplexing along with CDM division multiplexing. At the end, the users will be able to read 4 resource element at the CSI will be allocated to users at 4 different resource element using different groups. Actually, I will go through one more case, which is row number 5. Row number 5 is very similar to the previous one, exactly almost the same, but it's more related to not frequency division multiplexing. It's using TD, which is time division multiplexing. You can find, for example, if you did the calculation, you will know that the frequency domain will be only at 4 and 5. The first 2 will be using the same location, but the first second two will be using as a symbol. I mean symbol, for example, time domain 5 and 6 here. So the first CDM group will be using the same locations here and be multiplexing together, and the second group will be using a different location, which is that's why we call it time division multiplexing at, for example, subcarrier 6, at subcarrier 6 here, as you can see here, and it will be using also sorry, the time symbol 6 here. So it will be using the same symbol, but two resource elements, which is 4 and 5, and code division multiplexing and so on. And this will be the final figure. It's same as the previous example, but this one it's having a grid 2 by 2. For example, the grid is using two symbols instead of one. The first one was using one symbol and was allocating four resource element in the frequency domain, but this one will be using only two frequency domain at two resources at the frequency domain and two symbols at the time domain. That's why this one is using time division multiplexing along with code division multiplexing, along also with frequency division multiplexing. Actually, this is we have more examples of this part, but I didn't add it here. Actually, it looks, as I mentioned, it's not really very important to understand this part, but this is just in case you want to go deep. This is how we explain it, and you have any question, you can raise it. The last part we are going to cover in next slide is about related to the high-level introduction about how the CSI-RS planning is being considered, and will be an easy part. So let's move forward. Okay, here, this is the last part in this video. It's related to the CSI reference signal planning. Actually, we don't have also control over this part. Usually it's being done like with different network planning and so on. But just to let you understand about it, the first part is relating to, for example, assuming that we have a density of 3. So for example, assuming the network having 4 sectors, this is how the planning should be done. That, for example, if density 3, for example, this means we should avoid this kind of CSI-RS to CSI-RS interference. So, for example, the first part should be starting from here and keeping three free resource elements, for example, for BD search and so on. So, and it will be shifted by one for each of the other sectors to avoid the CSI-RS interference to each others, but still this giving a chance also to the CSI-RS to be the search interference, but that's just planning to avoid CSI-RS to CSI-RS interference. This is assuming, for example, density of 3. Assuming you have density of 1, even if you have a 12 sector network, each one resource element can be allocating each different subcarrier can be allocating one density as shown here up to 12 up to 12 sector. But in general, high density, as I mentioned before in the previous slide, it's actually allow you to complete the measurement with more increased accuracy as mentioned here, but it will have higher overhead. And configuring the lower density, it's like increasing the scope of frequency multiplexing. For example, in case of you having, as you mentioned in the previous slide, for example, you have the CDM, different groups and so on. For example, CDM with different ports and different CDM groups. This can increase less number of ports. As you can see, most of the examples we have, it's actually using only density 1. So this one can increase the scope of the frequency multiplexing and time multiplexing as well. And this is actually the last part in this video. I hope if you like the content, please share it with your friends and press like and give your feedback in the comments. If you have any more information, please let me know. And I will be trying to cover more information about the CSI-RS, but this will be more into the part which relating to the channel state information. So stay tuned and see you.